Hello students, today we are going to learn about concyclic points and circumscribed and inscribed circles. So first of all, let us understand about concyclic points. So if you see a circle, and obviously you know that the circumference of a circle is made by so many points. Basically the points are joined to make that circle. So if we take any 3 point or more than that on the boundary of the circle, that means on the circumference of the circle, those points will be known as concyclic points. Okay, so if you tell it properly, it will be the points which lie on the circumference of the same circle. Okay, it cannot be I am taking one point from this circle and another point from this circle, like that. Okay, so in one single circle we have to take the points on the circumference. Those points will be known as the points. Okay, the points will be known as concyclic points. So let's say this is A, this is B, and this point is C. So that means A, B, C are the 3 concyclic points of the circle. With respect to the circle, you can also say centered O. Now from here only you can understand one property of concyclic points, that is, since they are lying on the circumference of the circle, so that means the distance OC, the distance OA, and the distance OB will be equal to the radius of the circle. Okay, so that means whenever we need to prove some given points, suppose 3 points or 2 points are given as 1, 2 and 2, 3. Suppose 2 points are given A and B. Alright, and the center of the circle is given as O or C, it can be also written. Suppose this is given as 1, 1. So if you have to prove that, show that the points A and B are concyclic or not, what to show? The distance OA we will show. Okay, distance of OA equal to distance of OB. If we can show that, or it is coming like that by using the distance formula, in that case we can easily say yes, A and B are concyclic points. Okay, but if OA is not equal to OB, in that case we will say that the 2 points A and B are not concyclic points. Okay, that means they will never lie on the boundary of the same circle. Alright, after that, what is the next thing? That is circumscribed and inscribed things. Okay, so what are the terms mean to us, that we have to know first. So first thing is circumscribed. Circumscribed, and there will be inscribed also. Okay, what is the meaning of circum? Circum means, already you know that circumcircle means, or circumcenter, or those terms were also there, circumference. Okay, circumference means the boundary. Okay, so circumscribed means whatever will be outside something. Okay, and inscribed means obviously inside something. Circum means outside, in means inside. Alright, so how it will look? Now circumscribed circle, if I talk about circumscribed circle, in that case obviously circumscribed circle, that means circle will be outside and some other figure will be inside. How it will be? Suppose I am just joining these 3 points A, B and C, then what we will get? A, B and C, we will get the triangle ABC inside the circle, correct? So in this particular case we can easily say that the circle centered O is the circumscribed circle to the triangle ABC. Okay, that means some other figure is inside and outside there will be the circle. That's why it is named as circumscribed circle. Similarly, obviously inscribed circle if we want to take, in that case suppose I am just drawing one triangle outside that. Alright, here I have taken a little bit bigger circle, so it will just come out. Let me take a smaller one. Alright, let me take a smaller circle here. So just like this, suppose. Okay, now if I want to make it an inscribed circle, just draw the triangle like this. Okay, since it's not decided which one is to be where, so just in this way I'm drawing. Okay, so this triangle, if I name it P, Q and R, now you see the triangle is outside but the circle is inside. So that means this circle is inscribed circle to the triangle PQR. Okay, so that is the meaning of circumscribed and inscribed circle. Now let me show you some other figures. Okay, so here you can see circumscribed circle, that means the circle will be outside, so obviously some other figure will be inside and the vertices of those figures will be on the boundary, correct, of the circle. So that means here you can see the triangle, already I have shown you before. So triangle inside and circumscribed circle, so that means inscribed polygon. Okay, circumscribed circle and inscribed polygon, so that is inside. So here it is inscribed triangle, here it is inscribed quadrilateral. Okay, 4 points are lying on the circle. Here it is inscribed pentagon, here it is inscribed hexagon, and all the 4 cases are of circumscribed circle. Okay, so in general, if we want to say the inside figure, that is inscribed polygon, it may be triangle, it may be quadrilateral, it may be pentagon, hexagon, and so many polygons we can draw. And you can notice that here the gaps are getting lessened down. Here the gap, here it is a little bit lessened down, here again a little bit lesser, here again little bit lesser. So that is the case when we increase the number of sides of inscribed polygons. Okay, and let me show you some inscribed circles also. See here, inscribed circle and circumscribed polygon. So inscribed circle means the circle will be inside the other figure. So here you can see it is inside a triangle, this circle is inside a quadrilateral, here 4 sides are touching. Okay, 4 points at 4 points. Here also it is pentagon, it is hexagon. Again, circumscribed polygon means the polygon is outside. Okay, circum. So that means it's a triangle, quadrilateral, pentagon and hexagon. Now in general it is polygon. Okay, now here you can notice for triangle it will touch the circle again at 3 points, for quadrilateral at 4 points, for pentagon at 5 points, and for hexagon it will be similar. Okay, and here also you notice the gaps are getting lessened down as we increase the number of sides of the polygon. One more thing, that is in case of inscribed circle, the center, okay, center of that circle will be known as in center. Okay, so this center for each of the cases, okay, for each of the cases the center will be known as in center. And similarly for circumscribed circles, each of the centers, okay, each of the centers of the circles will be known as circumcenter. Okay, circumcenter, in center, circumscribed circle, inscribed circle, circumscribed polygon, inscribed polygon, and above all of them are concyclic points. The points will be known as concyclic points. Okay, thank you. That's it for today's class. Bye bye.